Right, so and hopefully what will be my last video of this lesson, we're going to look at some common types of behavior where a limit does not exist. And I'm going to show you 3 graphs. I'd like for you to know what these types of graphs are, and I'd like for you to also know these types of behaviors. So what behavior and what graph are associated with each other. So the first one would be if the function approaches different y values from the left and from the right as x approaches c. And so if you will look at the graph, I'm going to try to color code it for you. So from the left, as I'm approaching 0. So in this problem, my C value, in fact, I'm going to go ahead and write that in over here, the limit as x approaches 0. This is really what I'm looking at. As x is approaching 0, I have a y value of, in this case, -1 from the left. From the right, as I approach 0, as I approach an x of 0, my y value is actually at 1. So from the left, I have -1. From the right, I have +1. When those values are different, as they are in this case, as x approaches c, in this case as x approaches 0, then we say the limit does not exist at x equals c, or in this case, x equals 0. I will let you abbreviate does not exist by DNE, that limit does not exist. So I don't want you to mistake this statement and say, oh, that picture, that's the one where the limit does not exist. That is true, except you have to state a specific C. That limit does not exist as x approaches 0. If I were looking at x approaching some other number, like let's say x approaches 1, from the left of 1 and from the right of 1, I have y values that are the same. They're all 1. So you do have to be specific that at a certain x value, the limit does not exist for this type of graph. So that's one common type of behavior where a limit does not exist. A second common type of behavior where a limit does not exist, this would be this graph, if the function increases or decreases without bound as x approaches c, then the limit does not exist at that c. So again, in this example, the x value where this is happening is when x is a 0. So the limit as x approaches 0 in this function does not exist, because from the left, I have this increasing without bound. From the right, increasing without bound. That limit does not exist as x approaches 0. And then I'll have to scroll up